lesson 12.5, we're going to talk about symmetry. There's a couple different kinds of symmetry that we're going to focus on. Yeah. The first one is going to be reflection symmetry or line symmetry. And the second one is rotational symmetry. I'll pause this and let you copy that down, and then we'll talk some more. A figure is symmetric if there is an isometry that maps the figure onto itself. So we're looking for symmetry. Remember the four isometries we talked about? Can someone tell me what they are? What's one of them? Caleb? Slide or translation is the other word for that. What's another one? Rotation. Jacob? Reflection. And the last one? A glide reflection. Good. So we flipped it over and translated it, right? So those are our four isometries. And so we're saying these figures will have that kind of symmetry if they can be mapped onto each other from one of those isometries. Reflection symmetry would be like this one here. If I can flip this left and right and end up right on top of it. See what I'm saying? It's still right on top of there, isn't it? Stay where I put it. Then it has a line of symmetry there, and that line is right down here. Okay? What if I flip this up and down? It's still symmetric, isn't it? So that must mean that there's a line of symmetry right through here. Is that a little low? Okay? So there must be a reflection line there. Another question is it rotational? Let's put it back the way it was. See that. Come on. I want you to see that as I move it around, it doesn't lose its shape. It still matches up right on top of the original. And if I didn't have anything there, you'd just be taking my word for it. So I have an original there. And so when I manipulate this, I end up in the same place. So here's my question. Can I rotate it? Is it mapped right on top to itself now? No. So if I keep rotating, it's not going to be perfect. Okay. Is it on top of itself? Yeah. I don't know why it's center rotation. It isn't actually at center. But anyway, I had to adjust it just slightly. But it does. It does rotate and land right exactly on top of itself. And so that means it's rotational symmetry. Rotational symmetry. What was my angle of rotation? What was it? 180. And what did this say? If it's 180, then it can be called what? I couldn't hear you. Point symmetry. Okay, it's point symmetric. It has point symmetry if it rotates 180 degrees. Okay? So let's go over to our buddy here. And if I flip this over, flip this over, we see we get exactly the same on the other side, don't we? Okay? If I flip him back over, put him back where he was. Come on. Huh? Oh, I know why. So this person represents us. We have that reflection symmetry also. If we drew a line right down through us. Unless you have something like I do, you've got one pinky's been broken and it doesn't quite match up exactly with the other one. Okay? And things like that happen. But otherwise, for the most part, we are symmetric. I think they have a special word for that called bilateral symmetry. And they use that term when they're talking about animals and people and things like that. That they have half their body matches up with the other half of their body. Okay? Is this person I drew here, is this reflection symmetry? If I rotate this around, is it on top of where it was? Is it now? Now. Yeah. Only when I get back to where I started, right? So that would not be rotation symmetry. Okay. Now, if you look at number 18 in the homework, is that the starfish?
No, 17
17
is the starfish.
is the starfish. They have a starfish drawn here, and I'll just whoa. Got a little carried away with this arm. Well, we'll pretend that I did a nice job on this. If this starfish was actually drawn like that one is, the question is there rotation symmetry or around a line, or is there reflection over a plane? Okay? Rotation around a line or reflection over a plane? So my question, what I want to do, I'm going to draw that picture actually on a piece of paper. I should have drawn it bigger. But here's my star, okay? And if I took a line and rammed this line right through the center of my starfish, okay, does it rotate? Does it have rotational symmetry? Yeah, if I rotate, how many legs are on there? 5. And so, remember when we cut that up? If I go all the way around, what's the angle? 360. But if I just go 1/5 of the way, what's the angle? 360 divide 5 is what, Alex? Well, keep your head up and follow along. What is 360 divided by 5? 72. And so every 72 degrees, I rotate this and land where I started, right? And have the same, and be in the same position. So that's what they're talking about. If you put a line through the middle of that figure, can you rotate it? So you're looking at that tiger. Isn't that a tiger on there, the next one? So you're looking at a tiger, you're thinking, if I put this thing on a grill, throw him on the Barbie, and throw a spear through the middle of him, I rotate him around, is he going to be in the same position ever? No. So he's not going to have rotation symmetry, is he? All right? If I took this plane and I machete and cut right down through the middle of me with this plane. Okay? Let me help you. So here's my plane going right down through the middle of my body. Am I reflection symmetric on both sides of this? Yeah, I am. So that tiger is going to be reflection symmetric, but not rotational symmetric. Okay? All right, today I want you to begin 1 through 47 odds. I say begin because some of you still need to finish up your other, and you may not have time to finish. And I'm not concerned about homework today. You're going to have 2 days to work on the project, and you may not need that much time. And so 12:6 we'll talk about tomorrow, and that'll lead us into tessellations and our tessellation project. Okay? And then on Friday you'll have class time just to work on your project or any other homework you don't have done. All right?